Hi everyone, in this video we are going to see about the multiplexer. It is also called as MUX. It is one of the combinational circuit which has more than one input line and only one output line, and this should be performed with more than one selection line should be in the multiplexer. A multiplexer selects the information present from one of the any input lines depending upon the logic status of the selection inputs and routes it to the output line. Normally, there is the equation that 2 power n is the input lines and n is the selection line and 1 is the output. So the equation can be written as 2 power n is to 1. 2 power n is the input and the n is the selection line. For example, the n is equal to 1, which means 2 power 1. So 2 is to 1. 1 output, 2 input and 1 selection line. That is 2 to 1 line multiplexer. This is a simple block diagram with 2 power n data inputs, n control signals and 1 output. We will see 2 to 1 line multiplexer. Here there is only 1 selection line and 1 output and 2 inputs. 2 inputs is I0, I1 and selection line is S and the output is Y. This is a simple logic diagram for this 2 to 1 line multiplexer. We look into the truth table. The selection line is 0 and 1. The output is Y. Output Y is I0 and I1, which means when you are selecting the line 0, the output should be the output in the Y should be I0, whether the I0 may be 0 or 1. Similarly, when we are selecting the line 1, the output Y should be I1. The I1 may be 0 or 1. And the next thing is 4 to 1 line multiplexer. 4 to 1 line, that is 2 power n is to 1, n is equal to 2. So 2 power 2 is 4. So there is 4 inputs and 1 output and 2 selection line S0 and S1. See the functional table first. So 0 and 0 means it is I0, 0, 1 means I1, 1, 0 means I0, I2, 1, 1 means I3. Look into the logical diagram. It shows the 3 input AND gate with I0, selection line S0 and selection line S1. The selection line which has 2 things, that is one is NOT gated and another one is direct inputs. So before see this logical performing operations, we will see the equations. Y is equal to I0 into S1 bar S0 bar plus I1 S1 bar S0 plus I2 S1 S0 bar plus I3 S1 S0. This is the equation. With this equation we are drawing this logical diagram. Okay, we will see the inputs. One example for the specifically for one input lines. When I0, look into this I0, we are giving I0 as 0. See the selection line 0, 0, which means you are giving the selection line input as 0, 0. The input from I0 should appear in the Y, whether the I0 may be 0 or I0 may be 1. You are giving S1 0 and S0 0. Look into this line of S1. It is not gated and it moves to first AND gate, and also S0 is also not gated and it moves to first input, first AND gate. So 0 is the I0 value and 1 is the S1 and S0 value, which is complemented using NOT gates. So for AND gate, any one input is 0, the 0 will comes out and the Y is 1. This is the thing. It does not bother about the other inputs because we are selecting the line as 0, 0. So the I0 should be I0 will appear in the Y. The same thing, 0 and 0 for the selection line, it is complemented and it is given to the AND gate 1 and 1. We are giving I0 as 1. So 1, 1, 1. So AND gate gives the output as 1. So it will appears in the output Y as 1. This is the operation of multiplexer. Thank you.